So in looking at the power rule, it's very nice to have things written as a power or an exponent. And we didn't see anything that dealt with a fraction. We had fractional exponents, but not a fractional base. So let's see here. We want to go back through exponents a little bit here. And I want to remind you of negative exponents. Because if you see something in the denominator of a function, you may want to pull it up to the top. Or you might want to move it to the bottom if it's up top. But if you had an x to the n in the denominator, you could pull that up using a negative exponent. Or if you had an x to the negative n in the bottom, you could pull it up as a positive. So a negative exponent moves things across a fraction. Usually you're taught not to leave negative exponents, but in this case we're going to find that negative exponents, as long as they're in the top of a fraction, are very helpful. The other thing is rational exponents, and if you have an exponent that is a fraction, the denominator of that really means a root. So the nth root of x can be written as x to the 1 over n. Or the nth root of x to the m can be written as x to the m over n. Okay? So we can get our fractional exponents this way. So what we're going to do is just a little bit of review from college algebra, and we're going to try and rewrite some statements that have exponents or roots and make them all where they don't have denominators with variables in them and don't see a root. So the first one is 5 over x to the 9th. So the 5 is in the top. I'm going to leave it there, and I'm going to bring the x to the 9th up as x to the negative 9. Okay. Now you were told to stay away from this in pre-calculus, but this is what you want in calculus, because now it's in a place where we can apply that power rule. We can pull the negative 9 out front and decrease it if we're taking a derivative. Some subtle differences here. Next we have 1 over 5x to the 9th. Well, that's 1/5, so we don't really need to bring the 5 up, but we can bring the x to the 9th up as x to the negative 9. Okay, I'm writing these in the best way to make a take a derivative. Next, square root of 3x. I can separate that into square root of 3 times square root of x, so I'm going to write it as square root of 3 times x to the 1/2, using a rational exponent to represent a root. The next one, 3 times the square root of x, would be 3 times x to the 1/2. So I just want you to also see some subtle differences here. The next is 7 over 2 times the 4th root of x. Well, we can keep the numbers where they are, so that can be 7/2. That's just like a coefficient. And the 4th root of x is x to the 1/4, but since it's in the bottom, we'll bring it up as x to the negative 1/4. Okay. The next is 7 times the 4th root of x over 2. So once again, the 7/2 is fine, but that'll just be x to the 1/4 since it's already in the top. So notice in all these cases, I'm not leaving x in the denominator. The next one, 24 over x to the 11/3. Well, I really don't want to mess with that, but I don't want it in the denominator either. So bring it up as 24 times x to the negative 11/3. And the next here, I'm not trying to trick you, but it's x over 3x to the negative 6. Well, we can leave that 3 in the bottom as 1/3. But think about what we have here. We have x on top, and if we bring the x to the negative 6 up top, it'll be x to the 6. So we can clean this up as 1/3 x to the 7th. Okay, do I have another row? Yeah, I have a couple more. Next, 5 times the cube root of x to the 4th. The 5 is not under a root, so we'll just leave it there. The cube root of x to the 4th will be x to the 4/3. The root goes in the denominator of the exponent. Okay, x to the negative 7th over x to the 4th. We want them both up top, so negative 7 will stay up top, and we'll bring the x to the 4th up as x to the negative 4. So if we combine these, this will be written as x to the negative 11. In all these cases, you should be seeing that we could apply the power rule in all these. Okay, not so much the way they started, but now we can. The next one, 3 times x to the 4th times x to the negative 7. 3 stays there. We'll add the exponents. So it'll be 3 times x to the negative 3. And the last one, I've got 5 times 1 over x. That'll be 5 times x to the negative 1. So just make sure you're getting comfortable using these exponents. Okay? Writing things as exponents because the power rule is going to be the easiest rule we have to use.